Yes, please. Good evening, students.
Good evening.
Yeah, so we will continue from the last class. The last class we are discussing about the limit and what is exactly the meaning of limit. So we will see one problem. What is the meaning of limit is not existing? Generally, limit is not existing for piecewise functions. Are you aware of the meaning of piecewise functions? Anyone? Are you aware of the meaning of piecewise functions? How many people know y is equal to GIF function? Y is equal to fractional function. Anyone knows about these functions? Y is equal to tan theta. It's a piecewise function. Y is equal to cot theta. It's a piecewise function. There is no continuous in the function. Suppose if I'm taking the y is equal to x, it is a piecewise function. Greatest integer function y is equal. Anyone having any idea about these functions? I already told you. Try to recollect. Anyone? See, this is piecewise function. You can see these different pieces. Or I will show the GAA function or way it will looks. See this one. Anyone saw this kind of function? This function is called GAA function. So the function is like pieces. From here to here, one piece, one piece, one piece, one piece, one piece, one piece. These kind of functions are called piecewise functions. Suppose if I am having a function y is equal to x square, and I am asking you to verify the limit of the function at x tends to 0. Find the value of y at x tends to 0. F of x. That means if I'm substituting the value 0 minus x square, I will get 0. If I'm substituting the value 0, x tends to 0 plus also, I will get 0. And limit x tends to 0 also, the limit is 0. That's it. Left hand limit, right hand limit, and value 3 at 0. All the three values are same. Assume y is equal to x square. And approaching 0 means what? Either it is 0 or either it is 0.001 or either it is 0.90 minus. 0 minus means how much approximately? What is the value of 0 minus? Minus 0.001. If I'm taking this one, the square will be 0 square is 0. This will be 0.0000001. This also plus 0.00001. So which is approximately all are approaching 0 only. But if I'm taking another function where my f of x is like a piecewise function, it's a constant function for x less than or equal to 0 to x greater than 0. That means if I'm taking the graph for this, for all values which is x less than or equal to 0, the f of x is 1. That means and for values which is x greater than 0, that is x less than or equal to 0, x is 1, x greater than 0, x is 2, in open interval. This is a graph for y is equal to f of x. It's a piecewise function. From minus infinity to 0, this is the graph, and 0 to infinity, this is the graph. So how we can discuss? If I'm asking find the value of the function at 0, at x is equal to 0. If I'm taking limit x tends to 0, f of x will be equal to, at x is equal to 0, the answer is 1. Limit x tends to 0 minus f of x. For less than 0, 0 minus means x is less than 0, which is equal to 1. Limit x tends to 0 plus. 0 plus means slightly greater than 0. Your f of x is equal to 2. This is your left hand limit. This is your right hand limit. And left hand limit is not approaching the right hand limit. Both are different values. We can say, what is the conclusion we can say? Here, f of x is not exist at x is equal to 0. How I can say the f of x value is not existing at x is equal to 0? With the help of the limits concept. If the limit is not existing at that point, then the function is not valid or not exist at that point. So this is the best use of the limits in maths or physics for us. We can able to identify the situations where it does not exist and where it does not define properly. Understood, guys? What is it saying?
Yes, sir.
Now, how to conclude the limits for different functions? First, we are starting with linear function. Consider a function f of x is equal to x plus 10. And I will get a graph. X plus 10 graph, how it will look, students? X plus 10 graph, how it will look? If I'm taking x is equal to 0, f of x is equal to 10. If I'm taking f of x is equal to minus 10. This is a graph of y is equal to x plus 10. Y is equal to x plus 10. So if you see, you take any point here. I'm taking at x is equal to 5. What is the value of the function, whether it exists or not? Limit x tends to 5 minus f of x must be equal to limit x tends to 5 plus f of x must be equal to limit x tends to 5 f of x. I'm using the tabular column, x value and it f of x value. Quickly, everyone can calculate what is the value of f of x if x is 4.9, if x is 4.95, and if x is 5, 4.995, and if x is 5, and if x is 5.001, and if x is 5.01 and 5.1. Calculate the f of x value in these cases. Jitin, Hamsini, please. What are the values? Substitute in the given equation. Let me know what are the values you are getting. This I am getting 14.9, 14.95, 14.995, 15, 15.001, 15.01, 15.1. What we can observe here, if I am taking these three values, if limit x tends to 5 minus, the f of x value is almost approaching 15. Limit x tends to 5 plus, f of x value almost approaching. Suppose if x is slightly greater, but almost it is approaching 15 only. Limit x tends to 5, f of x is 15. So the value of the function at x is equal to 5 is 15. So existence of the limit is possible at x is equal to 5, or we can say the value of the function at x is equal to 5 will be equal to 15. Same as, can you identify existence of the limit for y is equal to x cube? Take the x values at x is equal to 1. If at x is equal to 1, you have to take the values like this. Less than 3, 1, 3 values. And 1, 1.001, 1.01, and 1.1. Calculate the y values and let me know what is your answer. Anyone got the answer? What are the values of this tabular column? Please, guys, many are here. Namsini, Nitin, Arshida, Felix, Subrajit, Raghav. What are the values of this? If I am substituting 0.9 in x cube, I will get 1.71. This will be 1. Sorry, guys. Y is equal to x cube. What is 0.9 cube? How much you are getting, students? Guys, some response.
So 0.72.
0.729. Correct?
Yes.
0.99 cube. 0.970299. Same as 0.999 power cube. This is 0.997. 1 cube is 1. 1.001 cube. It's coming 1.003003. 1.01 cube. 1.03. 1.1 cube. 1.33.
1.33.
See, what I can conclude from here, these are the values which is almost 1 minus. These are the values 1 plus. This is 1. When x is approaching 1 or going little bit away from 1, but almost equal to 1, both are approaching 1 only, the y value is also approaching the same. So limit x tends to 1 minus f of x will be equal to limit x tends to 1 plus f of x will be equal to limit x tends to 1, f of x will be equal to f of 1, which is equal to 1. So here the limit is defined or exist at x is equal to 1. X cube is having defined properly at x is equal to 1. So from this, if you want, you can take some other equation. So most of the algebraic expressions, either linear equations or cubic and quadratic equations, are having limit can exist at any point from minus infinity to plus infinity. If I'm taking a linear equation, the limit exists at every point except minus infinity and plus infinity. Even if I'm taking the square function also, it will exist everywhere. So how I can say using the graph, because in the first lesson we done with the graphs. Mostly if there is no cut in the graph, those kind of graphs limit exist. But this is not compulsory. So to keep as a like a rough idea. So how I can say by using the graph. Suppose if I am taking y is equal to tan x, the limit does not exist at 90 degrees. I will prove here. But same function, if I am taking y is equal to x cube, suppose if I am taking y is equal to x cube, this is a graph. If I am taking y is equal to x power 4, this is a graph. If I am taking y is equal to x square, this is a graph. X power 5, x power 7, x power 9. See these graphs, even if I am zooming out, everywhere the value is approaching it to a single value and there is no break here. So almost all algebraic functions, square functions or cubic functions or biquadratic functions are always limit exists at any point. That means from minus infinity to plus infinity, the limit will exist. We can conclude. So now we will see some other functions, cyclic functions we will see. One or two cyclic functions, how to discuss. I'm taking the sin x function. So existence of the sin x at pi by 2. Existence of the sin x at pi by 2. So the question is like this. F of x is equal to sin x. Find the value of the function at x is equal to pi by 2. So for this, if I'm doing with tabular column, I can take pi by 2 minus 0.1, pi by 2 minus 0.01, pi by 2 minus or plus 0, pi by 2 plus 0.01, pi by 2 plus 0.001. So here I am getting the values like this: 0.9950, 0.9999, and this is 1. This will be 0.999, and this is 0.9950. See here, this part is called x minus, x tends to pi by 2 minus. And this region is called x tends to pi by 2 plus. And this is exactly x is equal to pi by 2. When x is approaching pi by 2, your sin x is also approaching 1. There is no dramatical or drastic changes if the value is approaching. So limit x tends to pi by 2 minus f of x, or if I'm taking sin x, pi by 2 minus limit x tends to pi by 2 plus and limit extends to pi by 2 or sin x, sin x, sin pi by 2. That is nothing but f of pi by 2. All are equal to 1 only. All are approaching 1 only. So here we can conclude existence of the limit is possible. Existence of the limit is possible. Is it clear? Students, what I'm saying? So sin x is also almost all exist everywhere from minus infinity to plus infinity. I can give one more question. Can you try this question, students?
Yes, sir.
Find the value of the given piecewise function find limit extends to 0 f of x where f of x is equal to x minus 2 for x less than 0, 0 for x is equal to 0, x plus 2 for x greater than 0. Check the value. Same way. I'm starting with is asking extends to 0. Limit extends to 0 minus f of x. That is, x is less than 0. If x is less than 0, f of x is x minus 2. So limit extends to 0 minus f of x will be equal to limit extends to 0 minus x minus 2. Your function is x minus 2. 0 minus 2 is minus 2. Limit extends to 0 plus f of x. That is, x is greater than 0 very slightly. If x is greater than 0, f of x must be equal to x plus 2. So limit extends to 0 plus f of x, that will be equal to limit extends to 0 plus x plus 2. The value is plus 2. And f of x at x is equal to 0 is 0, or limit extends to 0 where x is exactly 0, f of x is 0. Here what I can conclude is left hand limit is not equal to right hand limit. So what I can say, if I'm using the tabular column x and f of x, if x is equal to minus 0.1, the answer is minus 2.1. If x is equal to minus 0.01, the answer is minus 2.01. X is equal to minus 0.001, the answer is minus 2.001. At x is equal to 0, it is 0. And at 0.001, the answer is 2.001. At 0.01, 2.01. At 0.1, 2.1. If I am taking the graph for this, my graph will come like this. Where this point is 0, 0, minus 2, and this will be 2 comma 0. So at this value, it doesn't have any value. It might be 0 or it might be 2.01, it might be 2.001. All the three values are defining here when x is approaching 0. That's the reason what we can say this function is not defined at x is equal to 0. The limit of the function is not existing at x is equal to 0. Understood? What is the meaning of limit of the function is not existing for a particular value? Students?
Sir, for a particular value to be like for the limit value to be existing from both right hand side and left hand side, the nearer value should be the central value.
Correct. All three values must be same. See, this is where he is asking us to check at x is equal to 0. On the number line, this side, x less than, that is 0 minus values. On right side, it is 0 plus. So these three values must be almost same.
Okay.
But it
sir.
is not here.
Yes.
Yeah. Can you check this question? Find limit x tends to 1 f of x where f of x will be equal to x plus 2 for x is not equal to 1, 0 for x is equal to 1. Please solve this question. For x is not equal to 1, this is the value. For x is equal to 1, this is the value. How we can discuss this question? What is your answer? I'm getting the answer like this. Limit x tends to 1 minus f of x is equal to limit x tends to 1 plus f of x will be equal to how much? You will get 3. But it is not equal to f of 1. even though if it is not equal to f of 1, both the limits are approaching to the same value. Here the limit exists, but that limit is not equal to value of the function at that point. Existence of the limit is happening, but that limit is not equal to f of 1. So in this case, the left hand limit and right hand limit both are existing to the same point, but it is not equal to the value of the limit at that point. This is a very rare kind of questions we will face. In numericals, we will discuss these kind of situations little bit elaboratively. It will be useful for the differentiation concept. If it is not like this, even though limit is existing and but not equal to at that point, how to discuss? What is the difference between limits and derivatives? There we will discuss. Now, with the help of all these things, we propose few statements. Algebra of limits. It's very simple. Algebra of limits means, suppose if I'm having 2-3 functions are in addition, subtraction or multiplication, limit, I have to calculate limit x tends to a f of x plus g of x. What algebra of limits says, instead of struggling to calculate the limit of the both the functions simultaneously, you can calculate the limit x tends to a f of x separately and add the limit x tends to a g of x separately. This is one thing. Second one, same as for subtraction also, limit x tends to a f of x minus g of x. So no need to simplify. If you are able to calculate separately, you just separate it, limit x tends to a f of x minus limit x tends to a g of x. So if you are doing limits separately also same and together also same. This is only called algebra of the limits. How we can say this one? Let f and g be two functions such that limit x tends to a f of x and limit x tends to a g of x exist. Then the subtraction of two functions limit will be equal to limit of the functions separately. Subtraction also same, addition also same. Even limit x tends to a f of x into g of x can be written as limit x tends to a f of x into limit x tends to a g of x. So some books they will write limit like this, some books they will write limit. Both are same only, don't confuse. Same as for division also, quotient rule I can say. Limit x tends to a f of x divided by g of x can be written as limit x tends to a f of x separately, limit x tends to a g of x separately. So these rules will be useful to make certain questions very simple. That's the reason we are learning these rules. Are you clear what is the algebra of limits?
Yes, sir.
Suppose if any function is multiplied with any constant, we can remove the constant out and you can apply the limit. Suppose if I'm having a limit x tends to a lambda into f of x, where lambda is some constant. So this will be equal to lambda into limit x tends to a f of x. It's clear?
Yes, sir.
So shall we move some questions?
Okay, sir.
Find the limits First one is limit x tends to 1, x cube plus x square plus 1. Calculate and let me know what is the answer.
Three.
Clearly shows x cube is a existence at all points, x square is also existent at all points, 1 is a constant function. So straight away you can substitute and let me know. The answer is 3. Am I right?
Yes, sir.
Second question. Limit x tends to 1, x square plus x. What is the answer? So no need to check here because x square is a polynomial function of square functions. X is a linear function. We already proved both are limit exists from minus infinity to plus infinity open braces. So 1 plus 1 is the answer. Correct?
Yes, sir.
Suppose if I am taking the same function with limit x tends to 3. X square plus x. That means if I am applying the algebra of limit x tends to 3 x square, square function can exist at all values. X tends to 3 at x. So what is the answer? 9 plus 3.
9
Answer
plus
is
3, 12.
one more question. Limit x tends to minus 1. Don't confuse. 1 minus is different. Minus 1 is different. 1 plus is different. Minus 1 minus is different. Minus 1 plus is different. So limit x tends to minus 1. 1 plus x square plus and so on x power 10. Calculate the value and let me know what is your answer.
Nine.
Check it properly and let me know the answer.
One, sir.
Yes, 1 is the answer. You will get first one for x plus x is minus 1, x square is plus 1, x cube is minus 1, power 4 is plus 1, power 5 is minus 1, power 6 is plus 1, power 7 is away minus 1, power 8 is plus 1, power 9 is minus 1, power 10 is plus 1. So finally answer is 1. Shall I go for one more question?
Yes, sir.
Find the limit x tends to 1 x square plus 1 by x plus 100. What is the answer? Straight away 1 plus 1 by 1 plus 100. The answer is 2 by 101. Correct?
Yes, sir.
I'm doing like this. Limit x tends to 2 x cube minus 4x square plus 4x divided by x square minus 4. What is the answer? So if I am applying the limits right away, what I will get? 8 minus 16 plus 8 divided by 4 minus 4, which is coming as 0 by 0. I can't take it as 0. This is not equal to 0. This is called indeterminate form. That is unable to determine the value when it is in this format. When it is in this format. So we are having indeterminate forms. 7 indeterminate forms are here. So what are the 7 indeterminate forms? We'll see here. Whenever you are getting the question, we have to change the form and you have to apply the limit. The first one is 0 by 0. The second one is infinity by infinity. The third one is 0 into infinity. The fourth one is infinity minus infinity. Fifth one is 0 power 0. Sixth one is 1 power infinity. And seventh one is infinity power 0. Anywhere in any calculation, if you are substituting the expressions right away, if you are getting out of these 7 forms, any one, then you can say it is indeterminate form. When you face the indeterminate forms, how to react? So that says that format is not able to find out. If the question is in that format, we are unable to find out. So for that, you have to change the form of the question, form of the expression. So in this case, you can take the factors and let's see. So the numerator factors are limit extends to 2. If I am taking x common, this will be x square minus 4x plus 4 divided by x square minus 4 can be written as x minus 2 into x plus 2. Again, limit extends to 2. X square minus 4x plus 4 can be written as x minus 2 whole square divided by x minus 2 into x plus 2. Cancel. Now, if I am applying the limit, what I will get? 2 into 2 minus 2 divided by 2 plus 2. This will be 2 into 0 by 4. The answer is 0. So 0 is a defined form. You can't say it is indeterminate form. Understood? How to do if you got the expression is in the form of indeterminate? Students, are you clear what I'm saying?
Yes,
So
sir.
why forms alone we will call as indeterminates? I will explain you after the limits concept. First, let me finish the problem. As of now, these 7 forms you keep it in mind. Why, sir, 0 by 0, why we can't call as a 0? Why we can't take it as a 0? Infinity by infinity, why we can't take it as 0 or infinity? 0 into infinity, why we can't take either 0 or either infinity? That I will discuss with you later. Why these forms are called unable to determine, indeterminate? That I will discuss you later. Next question. Evaluate limit of the function where limit extends to 2x cube minus 2x square divided by x square minus 5x plus 6. Calculate and let me know what is answer. First, apply straight away and check whether it is determinate or indeterminate. If it is indeterminate, straight away your straight substitution will get the answer. If it is indeterminate, then you have to take the factors or something you have to eliminate.
Four, sir.
What is the answer?
4.
First, if I am substituting directly, 8 minus 8 divided by 4 minus 20 plus 4 minus 10 plus 6, it is 0 by 0, which is indeterminate form. So limit x tends to 2. If I am taking x square common, x minus 2, denominator x minus 2 into x minus 3. If I am applying the limit, x minus 2 cancel. Finally, I will get an expression of equivalent expression is x square by x minus 3. So this will be 2 square by 2 minus 3. The answer is minus 4. Is it clear? What is the answer? Students, are you clear what I'm saying? Shall I give you one more question? You can go for one more question. Students, please respond.
Okay, sir.
Find the limit. Limit x tends to 1. X minus 2 divided by x square minus x minus 1 divided by x cube minus 3x square plus 2x. Please calculate. Check whether it is determinate form or indeterminate form first. If I am substituting or take LCM and do try it, what you are getting? If I am taking LCM and multiplying or taking commons, all the things, I will get the expression like this. X square minus 4x plus 3 divided by x into x minus 1 into x minus 2. This is how I will get the question. Check whether you are getting the same expression or not. After that, substitute directly. If it is coming in indeterminate form, do the factorization in the numerator. After that, apply the limit. Anyone got the answer? Limit x tends to 1. X power 4 minus 4x plus 3. X square minus 4x plus 3 into x minus 1 into x minus 2 will be equal to 1 minus 4 plus 3 divided by 1 into 1 minus 1 into 1 minus 2, which will give 0 by 0 indeterminate form. So the same function I am taking to calculation x square minus 4x plus 3 divided by x into x minus 1 into x minus 2. The numerator I am taking the factors. I am taking the factors x minus 3 into x minus 1 divided by x into x minus 1 into x minus 2. X minus 1 cancel. If I am substituting 1 here, 1 minus 3 divided by 1 into 1 minus 2. The answer is minus 2 by minus 1. So finally, I'm getting the answer of this expression is 2. So the limit of this is 2. Is it clear? Have I done? Students, shall I go for one more?
Yes, sir.
Yeah, I'm moving to one more question. See here, if I'm having the question like this, limit extends to a, x square minus a square by x minus a. If I'm substituting directly a square minus a square by a minus a, I'm getting 0 by 0. Even limit extends to a, x cube minus a cube divided by x minus a. If I'm substituting directly a cube minus a cube by a minus a, the answer is 0 by 0, indeterminate form. Limit extends to a, x power 4 minus a power 4 by x minus a. Here also I am getting a power 4 minus a power 4 by a minus a, which is equal to 0 by 0. Even if I am taking limit extends to a, x power n minus a power n, where n is a positive integer, x minus a, the answer is a power n minus a power n divided by a minus a, 0 by 0. If any question is in this format, if you look into this, the factors of x square minus a square is x minus a into x plus a. Here if it is x cube minus a cube, the factors are x minus a into x square plus xa plus a square. If it is x power 4 minus a power 4, the factors are x minus a into x plus a into x square plus a square. Same as x power n minus a power 1, x minus a is always a factor, and remaining thing will come like this: x power n minus 1 plus x power n minus 2 into a plus x power n minus 3 into a square plus and so on, a power n minus 1. So whenever I am getting this format, I can rewrite as a formula: limit extends to a, x power n minus a power n divided by x minus a can be written as n into a power n minus 1. How I will get? If I am substituting directly, I will get 0 by 0. The factors of x power n minus a power n is x minus a into x power n minus 1 plus x power n minus 2 into a plus x power n minus 3 into a square plus and so on, a power n minus 1 divided by x minus a. If I am cancelling x minus a here, what I will get? Only this expression is remaining. Limit extends to a. If I am substituting a power n minus 1 plus a power n minus 2 into a plus a power n minus 3 into a plus and so on, a power n minus 1. So this is also a power n minus 1 and this is also a power n minus 1 because it is square. So finally we will get n times a power n minus 1. So that's the reason limit extends to a, x power n minus a power n divided by x minus a can be written as if it substitute directly, we'll get indeterminate form. And instead of factorization straight away, you can take n into a power n minus 1 is the value of the limit if the function is in this format. Hope you are clear what I'm saying. Students, are you clear?
Yes,
Yes,
sir.
sir.
So based on this, we will see a few questions now. Evaluate limit x tends to 1, x power 15 minus 1 by x power 10 minus 1. So if I'm substituting directly, I will get 1 minus 1 by 1 minus 1, 0 by 0, which is indeterminate form. Using the algebra of the limits, x power x tends to, sorry, before, so I have to do some modification in this. I'm dividing both the numerator and denominator with respect to x minus 1. And I'm applying the algebra of the limits. Instead of finding the whole expression, I am applying the limit separately for the numerator. And 1 can be written as 1 power 15 divided by x minus 1. And denominator also, I am applying the limit separately. X power 10 minus 1 power 10 is nothing but 1 and x minus 1. We know from the previous formula, the numerator value is how much? N into a power n minus 1 divided by 10 into a power n minus 1. So 10 minus 1. So the answer is 15 by 10. So finally we'll get 3 by 2 is the answer. Is it clear how I done this question? Please observe. Any doubt anywhere? If you are not understanding, please let me know, guys. Go through it. What is the formula I applied here? What is the formula applied here? Limit x tends to a, x power a, sorry, x power n minus a power n divided by x minus a can be written as n into a power n minus 1. This formula I applied here. If you are clear, I will go to the one more question. Students, clear? Shall I move to the one more question?
Yes, sir.
Next one is limit x tends to 0, 1 plus x under the root minus 1 by x. If I am substituting 1 plus 0 under the root minus 1 by 0, this will be 1 minus 1 by 0, 0 by 0. For this, what I have to do? So I have to change the expression. Limit x tends to 0. This is 1 plus x whole power 1 by 2 minus 1 power 1 by 2 divided by, how I can write 1 plus x? 1 plus x minus 1. So the denominator is x. But x is tends to 0. But I am having here 1 plus x. If x tends to 0, x plus 1 tends to 1. This x plus 1 I am assuming as y. If I am replacing this value, limit x tends to 0, y tends to 1, where y is equal to x plus 1. So y tends to 1, y power 1 by 2 minus 1 power 1 by 2 divided by y minus 1. So even though if it is not a natural number, still we can able to apply this format. So here how we will get 1 by 2 into 1 power 1 by 2 minus 1, which will be equal to 1 by 2 into 1 power anything is 1 except 0. So answer is 1 by 2. Here I changed the limit according to my convenience. If x is tending to 0, add the 1 on both sides. 1 plus x tends to 1. So if I'm replacing x plus 1 is y, then I will change the entire quotient into different format. From there, I'm going to calculate the limit of the given function. So this is one of the important method will be useful to convert the given question into a required formula. To convert the given question into a required formula. If you're done, we'll move to the trigonometric functions limits, handling the limits for the trigonometric functions. Shall I move? Students, I can move to the next one. Guys, we can move or we can meet in next class. Students, please respond. Students, struggle.
Sir, anything is okay, sir.
Sorry?
Anything is okay, sir.
Yeah. So we'll complete trigonometric functions limits also. Suppose if I'm having a limit x tends to 0 sine x by x. If I'm substituting directly 0 by 0 is coming, answer is indeterminate. So how to deal this question? Actually, the sine x is a wave function. I can able to expand. The expansion of the sine x. Anyone having an idea what is the expansion of sine x? Expansion of sine x. There is a concept called sequences series for trigonometric functions also. E power x, logarithm x. The expansion of sine x will be equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial. This is the expansion of sine x. If I am applying this expansion in place of x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus and so on. This is called infinite series. Infinite series. There is no ending for the series. So if I'm cancelling, limit x tends to 0, 1 minus x square by 3 factorial plus x power 4 by 5 factorial minus x power 6 by 7 factorial plus and so on. If I'm applying the limit except the first term, rest of all the things will become 0. So this will be 1 plus 0 plus 0 plus 0 plus and so on up to infinity. So the always 1. So from here we can conclude limit x tends to 0 sine x by x is equal to 1. So straight away we can able to apply this formula from next time onwards. Same as how to calculate the limit of a function for cos. Limit x tends to 0 cos x by x. So I am applying cos 0 by 0. The answer is 1 by 0. Answer is infinity. That's it. Straight away you can say it is infinity is a defined value. You can't say it is undefined. Infinity by infinity should not get. Understood? Students, what I'm saying? Suppose if the question is like this. Limit x tends to 0, 1 minus cos x by x. Now is a problem. 1 minus 1 by 0, which is 0 by 0, indeterminate form. So here we are using a little bit algebra first. So I have to change the expression form. 1 minus cos x by x can be written as limit x tends to 0. 1 minus cos x can be written as 2 sine square x by 2 divided by x. 2 sine square x by 2 divided by x. So this can be written as limit x tends to 0, sine square x by 2 divided by x by 2. Again, this can be written as limit x tends to 0 sine x by 2 by x by 2 into sine x by 2. So now if I am applying the limit, what I will get? If I am applying the limit, what I will get? Separately, I am applying the limit. X tends to 0, x by 2 tends to 0. And limit x by 2 tends to 0, sine x by 2. So this answer is 1 and this answer is 0. The final answer is 0. So next time onwards, limit x tends to 0, 1 minus cos x by x is equal to 0. This is also one more formula. We can able to keep it in mind. Now, limit x tends to 0 tan x or limit theta tends to 0 value of tan theta. So I don't know if I'm tan theta by theta, tan theta by theta. If I'm substituting directly 0 by 0 indeterminate form. And limit theta tends to 0, tan theta can be written as sine theta by cos theta into theta. And I am splitting into two fractions. Limit theta tends to 0, sine theta by theta into limit theta tends to 0, 1 by cos theta. This whole value is 1 and this whole value is 1 by 1. So the answer is 1. So limit theta tends to 0, tan theta by theta is equal to 1, which is equal to limit theta tends to 0, sine theta by theta. Both are same, which is equal to 1. Any expression is in this format, straight away you can say the limit of the function is 1. So this is my previous slide. This is the previous slide. Please let me know if you completed. I will move to the next one. Yeah. Is this slide is completed, Arvind? This is done. I can move to the next one. Students, please respond. Yes or no?
Sir,
Yes.
sir, why is limit of cos theta by theta not defined?
Limit of cos theta by theta, we said not defined. Limit theta tends to 0, cos theta by theta, this will be cos 0 by 0, that is 1 by 0, that is infinity. Who tell it is not defined? Its value is infinite.
So even for cot theta by theta, it won't be defined.
Cot limit theta tends to 0, cot theta by theta. If it is cot theta by theta, what you will get? What are the indeterminate forms I told you? Is 1 by 0 is in indeterminate form.
No, sir.
But if you are substituting cot theta, how much? Cot 0 is how much? Cot 0 is how much? What is the value of cot 0?
Undefined.
That is infinity by 0, correct?
Yes, sir.
So answer is 0 now. Or answer is what? Infinity by 0 is what? Infinite.
It should
I can write
infinity only.
Let's see how it will be. Limit theta tends to 0, cot theta by theta. This can be written as limit theta tends to 0, 1 by theta tan theta. and divide with theta and multiply with theta. So I will get limit theta tends to 0, 1 by theta square into 1 by limit theta tends to 0, tan theta by theta. From here, I will get 1 by 0 into 1 by 1. This is infinity. So here also I am getting infinity. Is
Okay,
it clear?
sir. Yes, sir.
It's not undeterminate form. It is a determinant whose value is infinity. That's it. Undefined value. Indeterminate is different. Undefined is different. So a few questions we will try based on this, and we will wind up the session. Only one question. Evaluate limit x tends to 0 sine 4x by sine 2x. If I am substituting directly, I will get 0 by 0. So what I can do from here? Limit x tends to 0. I am writing sine 4x divided by 4x into 4x. Limit x tends to 0 sine 2x by 2x into 2x. If x tends to 0, 4x also tends to 0, 2x also tends to 0. So limit x tends to 0 can replace with 4x tends to 0 sine 4x by 4x into 4x divided by limit 2x tends to 0 sine 2x by 2x into 2x, where xx is cancelled to 2 times. Now apply the limit 1 into 2 by 1 into 1. Answer is 2. Hope you understand what I done here. Is it clear, students? Anyone have any doubt before proceeding to the numericals? Tomorrow we are going to discuss numericals on limit, and once we done, I will explain the how to deal exponential functions and logarithmic functions in limits, which is not available in the textbook. Please keep it in mind. Tomorrow we will deal some exercise numericals, and rest of the time we will deal with logarithmic and exponential function limits, which is not available in the textbook. So please practice and come to the class. We will discuss in next class. Bye everyone.
Thank you, sir.
Yeah.
Thank you, sir.
Bye.